Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tear, and this is my next video in my series on the Math Lovers book, a 3-volume series I wrote from 2019 to 2022. And it's available on Amazon.com. I've said this in many of my other videos on this feature. This is about my 12th or 13th video in this feature. Up to chapter 2 of the first volume now, which is on natural numbers, and I'm talking about primes, which is section 2.2. And today I'm going to talk about a very important and old unproved result, conjecture. That's what that's called Goldbach's conjecture. So anyway, let's begin. So what does Goldbach's conjecture say? This is all I say about it in the book, by the way. Just one small paragraph about Goldbach's conjecture. Basically what it says, I think they say a picture's worth 1,000 words, so I might as well show you some pictures here. So what Goldbach's conjecture says is that every even number greater than 2, for instance 4, 6, 8, 10, so on, every even number greater than 2 can be represented as the sum of two primes and possibly equal. So for instance, 4 you can only write as 2 plus 2. 6 you can only write as 3 plus 3. But it seems like every bigger even number you can write in at least two ways. I think 38 is exactly two ways, if I'm not mistaken. 7 plus 31 and 19 plus 19. The number seems to keep going up as the even numbers get larger. And Goldbach conjectured this, I think, in the early 18th century sometime. I don't even know exactly when. And Goldbach was an amateur mathematician. He wasn't a great mathematician or anything. He came up with a few conjectures. I think he came up with another important conjecture regarding prime numbers, which actually was proven false. And I don't remember the conjecture offhand. But the jury's still out on this one. Nobody's proven it, nobody's disproven it. I think just about every mathematician in the world believes it's true, though, because statistically it looks like it's true. And just to explain these drawings here, the numbers, the even numbers, are the horizontal lines, and in the top left diagram they only go up to 28. So these aren't very big examples. And then the kind of diagonal lines, the blue diagonal lines going down and to the right, and the red diagonal lines going left and to the right. Those represent the primes that you're adding to get those numbers. So for instance, if you look at 28, I think there's three ways you can write 28 as a sum of, or just two actually. So yeah, a 28 can be written as I guess 3 plus 25. That's the one on the. Oh no, that's 5 plus 23. That's the point on the right. So I guess 5 is the number, the blue number on the top left. You can see there's a diagonal line going all the way down to the bottom, representing 5, and then there's a diagonal line going down to the left starting near the bottom. That's 23. So you see the 5 plus 23 is 28. And also, I believe 11 plus 17. So these pictures kind of show all the pairs of primes that add up to each even number in these triangles. And the top left only goes up to 28, but then there's a couple bigger ones. The one on the top right goes up to 50, and the one on the bottom goes up to 100, I believe. And I think 100 itself can be represented in 6 different ways as a sum of two primes. I think I can remember them all too. 3 plus 97, 11 plus 89, 17 plus 83, 29 plus 71, 37 plus 53, or 37, no, 41 plus 59, and 47 plus 53. Yeah, those 6 ways. And the number in general grows. I mean, it doesn't grow uniformly, but it does grow, and it looks like it's true, but nobody's proven it. And nobody even really knows how to prove it. And this is kind of an interesting fact about prime numbers. I mean, prime numbers are very irregular. I mean, they seem to be random, and there's a lot of conjectures that look like they're true about prime numbers, but nobody knows how to prove them. Another famous one is the twin primes conjecture. I don't talk about this in my book, but what twin primes are, they're primes that differ by 2. Primes that are kind of as close as they can possibly be, with the exception of 2 and 3. 2 is the only even prime, but 3 and 5 are, that's what we call a prime pair or twin primes. 5 and 7, 11 and 13, 17 and 19. They start out pretty common, but they get less and less common as the numbers get larger. As a matter of fact, they're a lot more uncommon than the primes themselves because the gap between primes tends to grow. But nobody knows nobody's ever been able to prove that they're infinitely many, even though statistically it looks like, I mean, almost every mathematician is certain that there are infinitely many twin primes. There's just nobody knows how to prove it. So there's a lot of results like that concerning prime numbers. A lot of conjectures. They're easy to state, but almost impossible, maybe even impossible to prove. So anyway, that concludes my video on the Goldbach conjecture. Thank you for watching. Long live math, and I'll see you guys next time. Bye.